Lesson 4, Translating and Simplifying Expressions. Let's first write down different meanings for the words add, subtract, multiply, divide, and equal. For adding, we could use words such as plus, sum, total, increase, more than, tally. For subtract, we could use decrease, minus, less than, take away, deduct, difference, for multiply, we could use times, product, double, triple. Divide, we can use quotient, half, quarter, factor. Equals, we can use is, balanced, equivalent, identical, same. These are just a few of the examples that we could use to mean add, subtract, multiply, divide, and equal. There are many, many more. Today we're going to first translate English into math, being that math is a language. We're going to translate them into expressions. Expressions means that there are no equal signs. So first, example 1 says add the quotient of 5 and x to 4. So add means plus, quotient is divide, and we're going to add the quotient of 5 and x, so we have to make this into a quotient, and we're going to add it to 4. Well, we use a fraction bar when we're talking about quotients, so 5 over x is added to 4. And then the directions say to express in simplest form. Well, this is as simple as it can get. Cannot add them together because they are not like terms. They do not have the same variables and exponents. Example 2, subtract 9 from, so that means 9 is going to come at the end. So subtract it from double the difference of 3 and r. Double means you're multiplying by 2. So there's 2 times going on. Difference means you're subtracting. You're going to subtract 3 and r. So you're going to be doubling 3 minus r. So 2 times 3 minus r. And then remember at the beginning it said we're going to subtract 9 from all of this. Now we need to express it in simplest form. So first we're going to use the distributive property to get rid of the parentheses. 2 times 3 is 6. 2 times minus r is minus 2r. And then we have that minus 9. Now we need to combine like terms. The 6 and the minus 9 are like terms. And 6 minus 9 is negative 3. So we end up with negative 2r minus 3. Example 3. Add negative 5 to the product of 4 and the quantity. Whenever you see quantity, that means there's going to be parentheses around something. And what comes after the word quantity is x plus 2. So we have x plus 2, and there's parentheses around him. So quantity of x plus 2 means that the x plus 2 will be inside these parentheses. And it says the product of 4 in that quantity. So 4 is on the outside of the parentheses. And at the very beginning, it said we're going to add negative 5 to all of this stuff, the 4 and the quantity of x plus 2. So negative 5 plus 4 goes at the beginning. So that's our expression. Now let's simplify it by using the distributive property to get rid of the parentheses. So I'll still have the negative 5 in the front, but 4 times x is 4x, and 4 times 2 is 8. Combine like terms, and the negative 5 and the 8 are like terms because neither one of them have a variable, and negative 5 plus 8 equals 3. So my answer will be 4x plus 3. Example 4. Subtract 12 from. Remember in example 2 when we said subtract 9 from. That means he's going to come at the end. So 12 is coming at the end. So let's move on and see what else this sentence says. It says the sum, which means to add, of f tripled and 4. So this stuff is going together. The sum of this stuff. Well, f tripled means 3f. And remember, we're doing the sum of this 3f and 4. So 3f plus 4. So the sum of f tripled, 3f, and 4, and we subtract the 12 from all of that. So combine like terms. The 4 and the minus 12 are like terms because neither one of them have a variable. And 4 minus 12 is a minus 8. So our answer is 3f minus 8. Here are some expressions that were already translated into math, and they just want us to simplify them. We're going to combine like terms. Like terms means they have the same variable and the same exponent. For example, negative 4x plus 6 minus 2x. This negative 4x minus 2x are like terms. So we could use the commutative property to rearrange this sentence before we simplify it by putting the like terms next to each other. So negative 4x minus 2x are sitting next to each other, and then we put the plus 6 at the end. Now combine like terms, and you get negative 4x minus 2x equals negative 6x. And then you have this plus 6 tagging along at the end. Example 6. Use the distributive property to remove the parentheses. 3 times x is 3x. 3 times minus 2 is minus 6. And we have a minus 5x at the end here. Use the commutative property to put like terms next to each other, and the 3x and the minus 5x are like terms. So I'll rewrite them in the front. And the minus 6, he doesn't have anybody that's like him, so he'll go at the end. Combining like terms, 3x minus 5x is negative 2x. And don't forget the minus 6, who is at the end. Example 7. Everything is lined up next to each other that are like terms. The 2x and the minus x are like terms because they both have an x. And the minus 2 and the plus 7 are like terms because neither one of them even have a variable. They're just called constants. So we can go ahead and combine like terms. 2x minus x equals 1x, and minus 2 plus 7 equals 5. So this becomes x plus 5. Example 8, we need to use the distributive property to remove the parentheses. So negative 3 times x is negative 3x. Negative 3 times a plus 3 is minus 9. 2 times x is 2x. And 2 times 6 is 12. Let's use the commutative property to rearrange everybody who are like terms. The negative 3x and the 2x are like terms, so I'm going to write them first. And the minus 9 and the plus 12 are like terms, so I'll write them next to each other. Now I can combine like terms and get my final answer. Negative 3x plus 2x equals negative 1x. And minus 9 plus 12 equals a plus 3. So my final answer is negative x plus 3. So why are 8a squared b to the first c to the third and 8a to the first b squared c to the third not like terms? To be a like term, it does not matter what your coefficient is, and the coefficient's the number in front. So my coefficients here are 8 and 8. It does not matter what they are. What we're interested in is if everybody has the same variable and the same exponents. So A, B, C, those are our variables and they are the same. So far it's looking good that they might be similar. But then we look at the exponents, and I have a squared here and a to the first right here. So we have to stop and say, nope, they're not like terms, because they both either have to be both of them a squareds or both of them a to the first. And if we continue looking, we see b to the first and b to the second. Those are not the same either. They both have to have the same variable, same exponent. C is the only one that is the same variable, same exponent. But all three of the variables have to have the same exponents to make them like terms. So this one is not like terms. Cannot do anything to these two terms. Cannot add them. All right, let's continue practicing simplifying expressions. I want to just look at what's on the left-hand side of the equal sign. And if it's possible, I want to simplify it. 2a plus 9a does simplify. They have the same variable and they're both a to the first, so that means we can add their coefficients. So 2a plus 9a is 11a. So 11a is what should be underneath this sticker, this Labor Day sticker. And if I move this sticker, there should be an 11a under here. And there is. So we just simplified 2a plus 9a and we got 11a. All right, example 10. I want to do the same thing. I just want to look at what's on the left-hand side of the equals, and I want to simplify it. What's on the right-hand side is my answer, and part of my answer is covered up. This Labor Day sticker right here is covering up part of my answer, and I want to figure out what part of my answer got covered up. So we're going to ignore the right side for a second and come back over here. I want to look at this left side, what's in this red box. I want to simplify this. And this is a fraction with a binomial on the top, has two terms on the top, and it has a common denominator on the bottom. If I were to work backwards and split this back into two fractions, it'll be easier for us to simplify it. So I can rewrite it as 5x over 5 minus 15 over 5, because they have the common denominator 5. Now I can simplify each fraction by itself. 5x divided by 5 equals 1x, minus 15 divided by 5 equals 3. So when I simplified what was in this red box, I got x minus 3. And my answer is over here. So what is hidden underneath the Labor Day sticker? I think it's an X because I see the -3 right here. Let's see if we did it right. We did. X minus 3 is the simplified version of 5x minus 15 all over 5. Our last problem, big on the state test. They love for you to find the area of just the shaded portion. They give you two shapes and then tell you to find just this blue area. And I call them the big minus little problems. That means find the area of the big shape, find the area of the little shape, and subtract. Both of these shapes are rectangles, and we know that we find the area of a rectangle with the formula A equals length times width. So I need to find the area of the big rectangle. And his length and width are 10 times x plus 2. 10 times x plus 2. And I use the distributive property to remove the parentheses, and I get 10x plus 20. Then I need to find the little rectangle. His length and width are 2 and 4, so I need to do 2 times 4, and 2 times 4 is 8. To find the area of just the blue part, I have to take the big area minus the little area. So that means I'm going to take 10x plus 20 minus 8. My like terms are the 20 and the minus 8, so my answer will be 10x plus 12. And that's the area of just the blue portion.